So once again, my name is Laine. My day job is I work with Kubernetes stuff. We at Senate host a lot of Kubernetes clusters for our customers, so other dev teams, really. Yeah, that's kind of my background, really, or what's relevant here. This presentation is called Your Ingress, Our Ingress, which is really that anything you expose outside of your Kubernetes cluster is kind of ours. There isn't really anything private unless you're logging things down with IP whitelists or other kind of mechanisms. So within Kubernetes, you have these kind of different methodologies of exposing things outside of your cluster. So you would run your application in a container inside of your Kubernetes cluster, but all network traffic would kind of be local to that cluster. If you wanted to expose something outside of that cluster towards the public internet, you basically have to do any of these things. So an ingress is kind of a typical solution within Kubernetes. It is a layer 7 load balancer, basically. So it routes traffic based on the host header in your HTTP requests. The other alternative is what's called a load balancer service. What happens basically there is that you create a cool little resource in your cluster, and the cluster goes and creates a load balancer in your cloud provider. And it just attaches a public IP to it, and it's exposed to the internet. Another solution you can do is you can do what's called a node port service. You're basically mounting a port from a container towards the port of the actual host server. And if this host server has a IP that's publicly routable, you obviously have exposed it to the internet. And then there are a couple of other custom solutions like Argo Tunnel, which is this solution from Cloudflare that does tunneling between your cluster and Cloudflare that can expose things. Inlets, which is this other routing tunneling thing that somebody's built. And then I've seen a couple of people solve these types of things with VPN solutions, where you're basically tunneling traffic from a cluster through a VPN out to a server with a public IP, basically. That's kind of a typical solution that you see with people who run on-prem Kubernetes clusters. And these are kind of the extreme solutions where it kind of goes outside of the bounds of what is kind of recommended. Yeah, so Ingress. Now that we're doing a joined meetup event with OWASP, I realize that everybody is not maybe that familiar with Kubernetes.
Is it possible to Zoom, Philip, or?
No, I didn't think about that. Yeah, exactly. There are a couple. Everybody who has as bad eyes as I do, there are a couple of seats here. If I'm saying something that totally does not make sense, because obviously now when I'm standing here, I realize that I'm presenting to a group of people who have mixed knowledge of these types of things. Please tell me. I kind of like open forums and open questions, so just shout out questions. But basically, this is kind of what an ingress resource looks like within Kubernetes. It has a definition of a service. We don't have to talk about services, but a thing you can do is a thing called a ingress class, where you define which controller the ingress resource should adhere to. And you could technically create a public class and a private class. The difference between if your service is exposed to the internet is if it says public or private. Do you think anybody will do anything, any kind of mistake here? Or, it's very easy when it is, you're not expected to do a couple of manual steps, open firewalls, all these types of things. When it literally is just writing public instead of private, it's kind of there are large risks there, especially if you're a lot of people building internal services that don't have authentication systems because, it's always internal traffic, so why do we need authentication? Then all of a sudden you've just exposed the unauthenticated application to the public internet that has access to your internal services. So, these types of things are really easy to do mistakes with. Same thing with services. So the service is kind of the thing that goes behind your ingress. You have the typical service, which has a type of cluster IP. But if you want to have a publicly routable IP attached to your service, you just change type to a load balancer. And it's on the internet. There are ways of doing getting private load balanced IPs, but that requires you to do some extra configuration that also can go wrong. So exposing things to the internet on Kubernetes is really, really easy. And it's great when all you want to do is build a quick application. I just want to have it out on the internet. And kind of that's the selling point. But when you realize when you're building things that some things are supposed to be exposed, some things are not supposed to be exposed, some things are never supposed to be exposed, it becomes a really difficult question of how do we stop people from doing stupid things? So the question is, what are we exposing? Do we actually know what we're exposing? Are we actually looking at these types of things? I know that I wasn't for a long time. Can we all say that, okay, I know exactly these services are exposed to the internet? And sure, you could manually go and check these things, but what happens tomorrow? Are we actually monitoring these types of changes? And especially for building multi-tenant solutions where you have development teams that are given free roam within their own sandbox in the cluster, they might not know better. It might be a situation where you give them the opportunity to create load balancing services, and they go and create a bunch of load balancing services that are publicly routable. And in certain situations, it might be that they have to do these types of things, and it is the right thing. But you want to have some kind of checks and balances, and really looking at what is actually happening. This is what happens when it goes wrong. This is actually a redacted screenshot from a Kubernetes dashboard that I found this summer, for a financial institution. It has cluster admin in the cluster. I think there was enough nodes for 100 gigabytes of RAMs and 74 cores. It had autoscaling on, so I could probably scale a lot larger. I may have created a namespace just to test. It is fixed now, but what they ended up doing was they messed up their configuration where they created a load balancing service instead of a cluster IP. I found this through Google. Google had indexed their Kubernetes dashboard, and I accidentally found it. I was a bit confused initially because I was like, wait, we don't use Kubernetes dashboards. So whose cluster is this? And I realized, I just clicked the Google link and it just gave me this. It took me a while actually to find the company. I had to go through their secrets to find a company name. So I had to tell them also that on top of just removing the access, they had to rotate basically every secret in their cluster because I had looked at every secret in their cluster to find a name. It's bad. Another thing we also found through Google, funnily enough, was another company that should not be named. We found their private Prometheus instances just sitting out there in Google. I found their dev Prometheus instance first, and then I thought, if I just replace dev with prod, will I get their production Prometheus instance? Yes. Yes, I did. And this was the exact same problem. They had just put type load balancer instead of type cluster IP. Helm Charts are great. This is a Helm chart that is available out there that, you guessed it, defaults to type load balancer. This Helm chart is for a project called Goldpinger that does a lot of network checks inside your cluster. And if you're using it, you're basically exposing things to the public internet without knowing it. That's kind of a tough shit. It's there are situations where people want to create public load balancers because, for example, if you want to do TCP load balancing for a service. So you can't really lock these types of things down because there are legit reasons for it. You just need to monitor it. So the challenge is now, and this kind of becomes a larger question of we have to start alerting on where or when we start exposing new types of services. If a new ingress is created that is publicly routable, somebody should probably know about this, today and maybe not a month later when somebody emails you and tells you, hey, I found your Kubernetes dashboard publicly on the internet. But we also want to find what are we exposing? And this is kind of a bigger question that I've started or built for a while now, since this summer. My hope was to do this presentation in like 2 months when I had a proper demo running, but that might come later. But building applications, you might, and this is kind of a typical solution, you're building a front end, and when you run this in production, you want some sort of OAuth login. But when you run it locally, you don't. You just want to expose it like without any authentication. And you do a commit where you mistakenly change something, and you disable authentication. How do we know that authentication is actually enabled on the thing that you're publicly exposing? Like, what are we actually exposing? Are we exposing metrics? That's the kind of a question. Like, how many people build applications that expose metrics? Yeah, some people. How many people expose metrics on the same port they host other publicly routable things? It happens, you know. It's really easy to just go, oh, I want to create my Prometheus metric server, and I imported the client, and I'm just running on the same port and sharing the HTTP server. And all of a sudden, you're exposing metrics, and that might be critical information. It might contain customer information. It might contain, worst case, like GDPR sensitive information. So, you know, these types of things happen pretty easily. And it's like, that's kind of the good and the bad thing with Kubernetes, is that it makes everything so easy. I'm just going to check time. I don't know what sorry. Yeah, I'll just go through this quickly. So what do we have out there that is kind of like commercially available? I'm guessing from the OWASP crew, Showdown is kind of a typical thing that you know of, right? Yeah. So for those that don't know, Showdown is a search engine for the public internet, basically. It crawls, or it port knocks basically all IPv4 addresses all the time. It is kind of cool because you can search things like, give me every IP out there that responds to this port, or that responds with these HTTP headers. I know that there are people out there who use Showdown to find Kubernetes dashboards. So they basically go, there are a couple of fingerprints you can do on a Kubernetes dashboard to determine it's a Kubernetes dashboard. And you can basically go, give me every IP that looks like a Kubernetes dashboard. Now let's see if we can actually sign in. So, you know, they have also built a solution called Showdown Monitor. So instead of being kind of this offensive tool, it becomes a defensive tool where you can give them IPs and hosts, and it will monitor your public endpoints and show you what ports you're exposed and things like that. It is a pay-for service, but it actually looks pretty good. There is a tool that I've tried out called Kube Showdown that kind of tries to automate these types of things within Kubernetes, where it can like update your Showdown monitors with the public IPs that you've exposed. It's a okay tool, I guess. I haven't really found any other like commercially available solutions out there that does these types of like monitoring solutions. So if you know of any cool solutions, please tell me. The thing that the next part of this presentation would be showing the DIY solution that I built. If you use Kube State Metrics, you know that you can get metrics on all the services that you have in your cluster and all the ingress solutions you have in your cluster. So you can easily, through a metric solution, figure out IPs that you want to port knock or endpoints that you want to do HTTP requests to. The thing that's missing here really is the fingerprinting. So things like determining, is there authentication enabled in this endpoint? That's kind of those difficult questions, you know, or does this solution expose the like metrics through the HTTP endpoint? And that's kind of like most people, you know, expose their metrics through /metrics. So a good solution is just to go test, can I reach /metrics? Is this Prometheus metrics I'm getting? That's kind of these types of things that we should start monitoring, because realistically, these types of things can't be done manually in a fast enough pace. And we have to protect other people who kind of don't really understand what they're doing, because their internet is sadly a dangerous place. So my conclusion is we have a long way to go. Things are difficult. Good thing is, I've started a smaller project where I'm working on these types of things. Hopefully, we in the future might open source it. I will update and show the results. So what I have right now that we're running, that we've tried out, is a feasibility study of, is it possible to basically, we have metrics from maybe, say, tens of clusters. Can we port scan every single public IP out there and determine what we're exposing? Can we look at every single DNS record that we're exposing and see if we're actually going to be reaching it? The bigger questions there of, what are we actually reaching? So, you're in the end kind of re-implementing a open source version of Showdown. But these types of things, I don't think that's been given enough kind of, yes.
So, I think you look at the wrong challenge. So how do you stop developers committing unsecure configuration? I know for Kubernetes check over, it's open source tool created by Bridge. You can use it to validate your configuration in the pipeline.
Yeah.
And I think Bridge is commercial, but it also commits the great pull request with fixes to insecure configuration.
Yeah, but that kind of solves one side of the problem, really.
Yeah, you still need the validation on the other side. So.
Yeah, but it's like it solves the Kubernetes configuration of making sure that, okay, for example, you're exposing a load balancer. That might be the point. Other situations, you have a faulty label selector. You have a label selector that is casting a too wide net, and you're hitting a bunch of containers that are not supposed to be caught in that label selector, and you're exposing other applications. I've seen that happen. So these types of things, I think, are very difficult to, even if I agree with you that some sort of linting or security check should be done for sanity in the continuous delivery pipeline. What we also have to look at is kind of the checks and balances afterwards. These types of things are kind of difficult. And I know that these types of problems have existed for a long time. It's like, obviously Kubernetes hasn't invented the risks of exposing things to the internet, and that's kind of why I think it's an interesting topic to discuss from an OWASP perspective also, and like looking at how do we solve these things before, or have we really just like gone like, okay, like hopefully we're not exposing things that are bad. I think one thing that Kubernetes has done is it's made the pace at we're exposing or shooting ourselves in the foot has increased a lot faster now. Before it was doing a ticket where please create this DNS record, and a week later you have a DNS record. Now it's create an Ingress resource. 3 seconds later, here's a DNS record pointing towards it. And so it's kind of a devil in disguise, I guess. Great. That was all for me. Unless we don't have any other questions. No, I guess not. Thank you.